I'm going to figure out how biodiverse something is using tea in coffee mugs. So how you can figure out how biodiverse something is you use species richness and relative species abundance. In species richness, there you count how many of each species in each ecoregion. How to find relative species abundance is you take that species in that ecoregion and divide it by the total amount of species in that ecoregion. And you compare that to other ecoregions to figure out how biodiverse they are. So, first ecoregion is this cup. And I will count how many tea. First one is the acai blueberry pomegranate tea, and there are 4. Next, the orange and cinnamon spice tea, and there is 3. And next is the green tea, and there is also 4. And there are no lemon tea, so there's 0 of that. The next is ecoregion 2. And there is lemon and ginger tea, 2 of them. There's 1 orange and cinnamon spice, and 1 acai and blueberry pomegranate. And then there's 7 green tea in ecoregion 2. So, write them all down, counting how much each tea is in each cup, which is ecoregion, and put that down. So for relative species abundance is, like I said, you add all those up, and you divide the amount of species richness of one of them with all the numbers. So I'll do that. And so here are the results. So for acai in ecoregion 1, there's 36.36%. And then of orange, there's 27.27%. And then green, there's 36.36%. And then lemon, 0%, because there's 0 in species richness. Then in ecoregion 2, for acai, 9.09%. For the orange, 9.09%. For green, it's 63.63%. And then for lemon, it's 18.18%. Now, how can we determine which ecoregion is more diverse with the tea? Well, ecoregion 1 is more diverse because it has a diverse amount of tea, which also has similar amounts. So, as you can see, there's 4, 3, 4, they're all a similar amount of numbers, and they're around the same amount, and the percentages are around the same. And when we go to ecoregion 2, there's a bigger difference. You go from 9% and then to 18%, but then all the way to 63%. So that's not as diverse as ecoregion 1.
The battle of the fittest. Is being fast, big, healthy, and strong always the fittest? Well, the first example on the left is, will a slow turtle or a fast cheetah be the fittest in this dense brush environment? Well, the turtle would be. Even though it is slow, it can camouflage itself in the brush environment. Next example is, will a small mouse or a large elephant be the fittest in this short grass environment? Well, the mouse would be. Even though it is small, it can blend in more with the short grass environment. Down to the next example this is a sickle cell. Having sickle cell is not seen as the fittest. However, in Africa, having sickle cell is seen as being the fittest. Having sickle cell in Africa can keep malaria away from the organisms. So usually sickle cell is not seen as being the healthiest, but in Africa it is because it keeps malaria away from people. The next example is, in regard to birds, having a shorter and stronger beak does not always result in them being the fittest. The environment may have flowers, therefore the birds must need a longer beak to reach the food instead of a strong, hard beak. So what about reproduction? With each of these examples, the organisms that are not the fittest either will die off, move to a different environment, or adapt. They can only adapt if they have the trait in their DNA to do so. With the fittest organisms, they will reproduce their characteristics, if it is in their DNA, down to their offspring. Natural selection does not only include having the right traits in an environment, but also having the ability to reproduce that desirable trait to the next offspring. The definition of convergent evolution is a kind of evolution that results in similar forms on different species. For example, the wings of bats and birds. Their wings have a similar structure because they have adapted in similar environments, but they are different species. Another example are thorns and prickles. They also are different species but have evolved similarly due to the environment. Last example are sharks and dolphins. Their structure is similar because they have also evolved in a similar environment. But again, they are separate species. So I created a worksheet for students that can practice the meaning of road regs. So here's the assignment. On the top it says to send each letter you need to add a stamp. Write in the stamp number definition that matches with the word on the envelope. So we have 8 envelopes and they all have a definition, and then on the bottom are the stamps with all the words that need to be matched for each definition. So we'll go through it and just see if you know them. So the first one, we'll go from top left to right and then down to the next one. The first one is heritable traits passed with DNA to aid survival. The stamp that should go with that letter should be adaptation. Now the next one, mechanisms coordinate internal functions. The stamp that should go with that one is regulation. The next letter is increased size or number of cells. The stamp that should go with that one is growth. Now next to the down to the next line, detect changes in environment. The stamp for that is sensitivity. Next letter, offspring produced from parents. The stamp for that one is reproduction. Next letter is ability for cells to specialize. That stamp is development. Now down to the next level, the letter is use energy to function. The stamp for that one is energy processing. Then the last letter is living organisms made of one or more cells, and the stamp for that letter is order. Now this is only the first part of the worksheet. The next part is you need a picture to go in that letter to send out. So on the top it says, now since you have the corresponding stamp to each letter, you now need to find the right picture to send. Write in the picture's letter that matches with the envelope and stamp. So again, we'll go back to the letters and attach the same picture that matches with the definition. So once again, going from the top left to right, heritable traits passed with DNA to aid survival. The picture that goes that one is A, and that's with the giraffe because it has adapted its neck through DNA. The next letter is mechanisms coordinate internal functions. The picture that goes with that is D because regulating the same temperature. The next letter is increased size and number of cells. That one, picture is E because there's more cells being created. Next letter is detect changes in environment. That picture that goes with is F because someone is sensing that the coffee is hot. Next letter is offspring produced from parents. That one's H because you have a parent, mother, and a daughter. Next letter is ability for cells to specialize. And the letter is B because as they're growing, they're specializing in certain types of cells. Down to the next level of a letter is use energy to function. And the picture that goes with that is C because photosynthesis, and it's using through photosynthesis energy. Then the last letter is living organisms made of one or more cells, and the picture that goes with that is G because this is Typically, this is how an organism is formed, but you can also be a cell and still be an organism. But that is my road regs worksheet activity for students.